And here, there is another topic which is in the, let me say, interest or public interest of the international emission legislation at International Maritime Organization, at the IMO, and that is black carbon and particulate matter.
And did you know that SICK has a long history in developing and producing sensors for particulate matter? So to get more insights about that, we invited Jörg and Mike. Jörg, we are curious to hear what you have provided for us. Let's get started, and I hand over back to Dresden. Jörg, the stage is yours.
Thank you very much. Hello, Ramona. Hello, Heinrich. Good morning, ladies and gentlemen, and welcome to SICK Engineering in Dresden. At SICK Engineering in Dresden, we have here our Research and Development Center for Dust and Particulate Matter Monitoring. And so here we are developing, and of course, finally, we are manufacturing dust particle monitors. Traditionally, we sell our products mainly into the shore applications. Our instruments are to find in all big industries, you can say, power plants, waste incineration, chemical plants, cement plants, pulp and paper, and so on and so on. But in the last years, we deliver more and more our monitors also in the maritime sector as well. And that's why in the following 15 minutes, we will tell you more about our dusty business on ships and ferries. For that reason, we prepared for you some video clips in which you will learn, for instance, how do our dust monitors look like, which measurement technologies we are applying in these monitors, and what has dust monitoring finally to do with maritime, traffic, and climate change. And with this question, we come to the central point, soot particles, also known as black carbon. And these black carbon particles are emitted, of course, also from ships and vessels. This black carbon particles coming out of the stack of the ships, and these particles are very small, very light, and so they can stay a very long time in the air, and with this they can also be carried around the globe. And finally, they settle down somewhere, also and unfortunately on the surfaces of the poles, in the Arctic or in the Antarctic, here. And the effects which will happen by these kinds of surface pollution on the ice will be explained by my colleague Mike, and that's why I'm calling Mike. Hey Mike, are you ready to tell our guests a little bit more about black carbon and all the topics around that?
Thanks, Jörg. Of course. In my opinion, we are facing two main impacts. First, the harmful fine dust pollution on coastal regions. The very small particles, sized smaller than micrometers, are breathed in by humans and can lead to serious health issues, including heart and lung diseases. These fine dust emissions are harming our environment too. Second, the acceleration of the melting process of polar ice due to the black carbon effect. Black soot as a fraction of particulate matter is setting on polar ice. The black soot absorbs the energy from the sun, heats up and accelerates the melting process of polar ice. So how to reduce these particulate emissions to reduce these impacts? Reduce ship traffic? Not realistic and feasible. Change from fossil fuels to gas? Possible, but most ships are diesel or oil driven today, modifications expensive, so not realistic in short time. Using high quality fuels, which produce less emissions within combustion processes, and monitor these emissions? This is a realistic path which is currently taken. Examples are the limitation of sulfur content in fossil fuels or the installation of scrubbers in the exhaust treatment process. And how can SICK contribute nowadays and in the future? SICK, as one of the leading manufacturers for maritime emission monitoring technologies, offers a wide range of solutions. Our dust analyzer monitors your dust emissions continuously, accurate and directly from the exhaust stack, so you always keep on track of your dust emissions. The main purpose of our customers to install our dust monitors from SICK are the enforcement of local regulations and the application for monitoring dust emissions, higher transparency of combustion processes which can be used for optimization, and to strengthen environmental responsibility, which is in line with a green image that can be a plus, for example, for cruise ship operator. In the near future, we expect a global regulation to measure and monitor black carbon due to the high awareness of the impact of humans and the environment. Hey Jörg, are you ready to introduce our guests to our dust analyzers, which we recommend for maritime applications?
Thank you, Mike. Hello, everybody. Now we are in SICK Engineering Dresden, and especially we are here in the production hall. We are producing here our particle monitors. Our particle monitors or dust monitors are based on two different technologies. It means we use two different technologies. One dust measuring technology is transmission or opacity monitoring, and the other technology we are using in our instruments is scattered light. But let's have a look at first to our transmission monitors, and the principle I have here on this sheet. The transmission monitor basically consists of two main parts. One part is the sender, the other part is the receiver, and we see here the sender and the receiver are mounted by a flange arrangement on a duct, on an exhaust duct, for instance. You know, in maybe all industry branches, you have chimneys, you have ducts where exhaust gases are finally drawn to the environment, and mostly these exhaust gases are dust loaded or particle loaded. That means you have particles inside of this exhaust. So if we want to know the dust concentration, the particle concentration, we have this monitor, and a light is sent from the sender to the receiver, and the light which is received here is of course depending on the amount of dust inside, means how much particles are inside, and finally this is also a measure of what is the dust concentration in milligram per cubic meter. That means when we would not have any dust inside, then this 100% light which is sent from the sender is also received here at the receiver. When we have dust inside, then of course the light will be weakened on the way from the left to the right, and so we will not have this 100% in our receiver. Well, practically our instruments, or a part of our instruments, transmission instruments, look like this. This is the typical arrangement I have in the drawing here. That means we have here the sender, and then we have here the receiver. And this, you see also the flange arrangement once again, is finally mounted at a stack, at a tube, and so we can detect the dust concentration. Well, this for the transmission monitoring principle and transmission monitors. And now let's have a look to our instruments which are using the scattered light technology. So let's have a look to the other dust monitoring principle. I mentioned it already, it is the scattered light monitoring principle, and this works like following. A light beam, a light source from the right side we see here hits a particle. This is the gray one, and when this light beam hits this particle, different optical effects are finally formed. This is reflection. Of course, a part of the light is reflected. Then we have deflection, diffraction, reflection, and also absorption. And altogether, all these kinds of effects, of optical effects, is called scattered light. And the scattered light finally can also be used for detecting the amount of dust particles in a gas. So we see here at the lower side, once again, the principle from the right side, the sender. In this case, we have a laser beam, and the laser beam hits the particle, and the particle forms all of these mentioned optical effects in all directions. And in a special angle, we placed at the other side or in front of this our receiver, and we received the scattered light. Well, but that's not all of the story. We distinguish two different kinds of scattered light monitoring principles. One is the scattered light backward measuring principle, and the other one is the scattered light forward measuring principle. We see here in this arrangement, this is one of our instruments, you can say. We see here the sender and the receiver are in one of the same in one of the same body, one of the same housing. And when the laser hits the particle here, the optic is sitting here, and the red beam you see here, this is the zone, or this is the range where the optical looks to the duct. And when the laser beam hits the particle, then the back scattered light is received. That's why scattered light backward measuring principle. Just the back scattered light we use in this principle to detect dust concentrations. In difference to the forward light measuring principle, the sender is the same position, you can say, but the receiver is in another position. And this is an angle of about 50 degrees. And here, in this range here, the scattered light is detected. The difference between these two measuring principles is the sensitivity. The sensitivity of scattered light forward measuring principle is much more sensitive than the backward measuring principle. That's why we produce backward monitors and also forward scattering monitors here in our manufacturing facility. Well, how looks it like in reality? This is such a backward scattered light monitor, as we have seen here. Both the sender and the receiver are mounted in this housing, and the sender sends the light beam to the duct, and the receiver looks also into the duct, and where the beam is crossing or hitting particles, the detector can also see that. This is just one of our instruments here. We have a portfolio of about 10 different types. But now the question is how can it look like in practice? And for this, we have in our last part of our presentation, we sent Mike to the Altair. This is a research vessel, this research ship, but he will tell you more about this and what he has done on board of this vessel. Okay, Mike, you are ready?
Thanks, Jörg, and hello everybody. Today, Mr. Tresk from the BSH and Head of Division Ships and Equipment will allow us to look behind the curtains on board of the new Altair, a German research ship. Hello, Mr. Tresk.
Yeah, hello.
What purpose does the ship fulfill?
The main task of the new Altair is RCC survey, the detection of shipwrecks and environmental monitoring. As a research vessel, Altair as a floating laboratory is also used for geological and oceanographic surveys and for development and testing of technical ship equipment.
Wow, interesting. Let's go on the deck to get more insights. When and for which reasons was the dust measurement technology equipped on the Altair?
Yes, the state-of-the-art research vessel Atair was built 2020, and it fulfills the highest emission and environmental standards in terms to the ecological footprint. And as you see in the engine room there, the motorization of the ship based on two different modes. The first mode is using liquefied natural gas, LNG, and the second mode is to use diesel fuels, including the emission gas post-treatments. We examine and compare both driven systems, and therefore the particular meter monitors from SIG are installed in the exhaust pipes of those systems.
We are in the area of the emission gas monitoring facilities, and we integrated the SIG technologies right from the beginning of the planning and construction under the profits from the newest availability measurement technology. Because of the low dust content in the exhaust, we went for the dust content SB100, which is based on the most sensitive dust measurement technology, the scatter rate light monitoring.
Mr. Trest, what do you think about the future development of regulations and the monitoring of ship emissions?
As it is known that ships also contribute to the air pollution. Today the focus lies on the minimization of harmful particulate pollutions near the coast. The accelerated melting of the polar ice due to black carbon emissions will also gain in importance in the future. Current tendencies, like the gradual lowering of sulfur content in fuel or the installation of regulations for exhaust after treatments, show that there are development on these topics. As a consequence of this development, most likely there will be legal limits for black carbon emission in the future.
All right. Thank you, Mr. Trest, very, very much for giving us the opportunity to catch a glimpse of the technology on board of the Atair.
Yeah, you're welcome.
All right, everybody. We hope you enjoyed our little journey to a real application of our dust monitoring analyzers. Thank you for listening. Goodbye and back to Dresden.
I almost lost the world. Hi, I'm back on stage and live, and waiting for interesting questions, or do you have some other remarks? Hi, Ramona. Hi, Henrich.
Hello, Jörg. Thank you very much. I mean, unfortunately, I haven't found a ball here. Otherwise, I would catch him up. Very interesting, and thanks for your detailed explanation about the technology and also the holistic portfolio we have in hands of around 10 different analyzers here. And of course, very nice to have a real customer voice and these insights from a real application from one of the newest chips we have here. Very interesting.
Yeah, that's very, very interesting.
We have two questions in the chat, Jörg, and that is first, does SIG Dust Analyzer portfolio for maritime purposes have any regulatory certificates?
The answer on this question is we are right now currently in the certification process with one of our scattered light instruments and with one of our transmission monitors. Yes, a clear yes.
Okay. And second question is, are there any global regulations already in force in relation to black carbon?
Hinrich, you know that better than me. And what we are heard in the last years, there's an ongoing, or there's a big ongoing discussion in these topics. That means especially to finally avoid the emission of that much black carbon particles as the world did it in the past. And so I think, and I expect in the future, in the near future, that there will be some regulations established quite soon. I think in the maritime Maritime Organization. Maritime, what is that?
International Maritime Organization, IMO.
Yeah. So, and I think they will establish quite soon a regulation which is finally valid for all the members. And we are here at SIG also working on this topic, and will finally in the future design a special or one or two special instruments, especially for the requirements on board of ships. Yeah.
That's good to hear, Jörg. Thank you very much. And of course, I can agree, and we heard it also from Kai Oliver Twest, that there are regulations coming into force, and it's of course definitely a topic at IMO in the discussion.